we will be looking at the October 2021 paper. We'll be looking at the multiple choice questions. And before we start, you're probably wondering, why is it an October paper? Aren't the exams usually in June? You see, this was during when the exams were cancelled during COVID. And this was the retake paper for those giving students an opportunity to retake their paper. Those times were very different. But it's October 2021. We're looking at the multiple choice questions. Let's make a start. Which statement describes electron negativity? Now, before we even look at the answers, electron negativity is the ability of an atom to attract a pair of electrons towards itself, which creates a permanent dipole. So, for example, if X is more electron negative, this will be delta negative, and Y becomes electron deficient. Now, having our understanding, it's a measure of the reactivity of an element. Reactivity of an element. Reactivity is to do more with sort of losing, gaining electrons or sharing electrons, bonds breaking. This is not about bonds breaking or electrons being lost or gained. The ability of an atom to attract an electron to become a -1 ion? No, it's a partial charge. It's a slightly negative. Let's look at D, the attraction of an atom for a lone pair of electrons. Attraction of an atom for a lone pair of electrons? No, it's the attraction of a bonded atom for the electrons in a covalent bond, as the definition shows over here. So the answer is C. Moving on. This question is asking, a chlorate ion has a -1 charge. What is the formula? Now you see a chlorate ion is Cl. We don't know how many oxygens there are. Let's call that X, and it has an overall -1 charge. Sodium is going to balance with that charge. Now you see the question, it tells you that it has a +7 oxidation number, VII 5 + 1 + 1. And that means to get an overall negative charge of the ion, there must be -6 would give you +1 overall. That means there must be 4 oxygens. -8 + 7 + 1 = 0. So the answer would be B. Yep, and the mark scheme supports that. Moving on. An unbalanced equation for the reaction of silver with concentrated nitric acid. Now you see a question like this. You can't really use normal balancing rules that we've learned in GCSE and even year 1 A level. You need to balance the electrons first, only then after do you balance it normally. You see, silver has got a 0 oxidation number here. Any element in its standard state has an oxidation number of 0. It goes from 0 to +1. So what's going on here? It's losing 1 electron. Now, nitrogen in the nitrate ion has an oxidation number. Let's see. Each oxygen is -2. Why is it -2? Each oxygen is in group 6, has 6 electrons in the outer shell, has a tendency to gain 2 electrons to have a full outer electron shell, has an oxidation number usually of -2, most of the time. Going a bit off topic here, but in hydrogen peroxide, which is this H2O2, oxygen in this instance actually has a +1 oxidation number. Because if you look at the oxygen, one side is bonded to one of its own kind, and one is a different element. That's why it's, in this instance, it's some +1. But anyway, back to the question. Nitrogen must be +5 for overall charge to be -1. It goes from +5 to, let's see what it is here, oxygen is -2, nitrogen must be +2. So can you see that nitrogen here, it is from +5 to +2, it is gaining 3 electrons. That means in this reaction, if that's gaining 3 electrons, those 3 electrons need to be provided by the silver. And so it's a 3-to-1 ratio, and it's 3-to-1, and then you just balance, put a big 3 there. And with the hydrogens, you got 3 oxygen here. You're going to need 2 oxygen here. 2 meaning the 2 oxygen here, because these nitrogen are going to be in a 1-to-1 ratio, and I believe that's correct. Let's just double check. Oh, and the hydrogens, because you've got 4 hydrogen here, we put a big 4 here. Let's see if this is correct. Yep. How was I checking if it's correct? I haven't looked at the mark scheme yet. You got +4, -1. So with the charges, that's the way to check. So that means silver and water should be a 3-to-2 ratio. 3-to-2 ratio, D. Yep, that is correct. Not a very straightforward question. There's quite a bit going on there, ladies and gentlemen. Even I was a little bit perturbed. Which sample contains the greatest number of molecules? Before we even answer this question, we know that 1 mole of any substance will have 6.02 times 10 to the 23 molecules in it. Mole of molecules. So really, whichever will have the greatest number of moles of molecules will have the greatest moles first. So we need to work out the moles. So it'll be 140 over 2426, 180 over 2430, 240 over 4858, and then 400 over 6 times 12, 72, 78. Quickly work those out. .38 moles. Six moles. 4.14 moles. 5.12 moles. So the answer would be B. 4B. Yep, that's correct. Ladies and gentlemen, one question that's been coming from students is that in the multiple choice, really, you know, it's only 15% of the marks, and 15%, it says you should spend maximum of 20 minutes. And obviously these videos are a lot longer. You see, with exam practice and heightened level of focus, you will be able to process these much, much quicker than I'm showing here. And I'm deliberately going slow so that we understand. But with practice, you will gain speed. Next question. It says chromium oxide is reduced to chromium by heating with magnesium. What is the minimum mass required? Before we attempt to answer this, we need to think about how much magnesium would it react with. This would give you chromium and some magnesium oxide. And to balance this, we put a big 2 over here. You got 3 oxygen on the left, so let's put a big 3 there, and so a 3 there. So it reacts in a 1-to-3 ratio. What is the minimum mass of magnesium required? How would we work this out? We would do 11.4 divided by the molar mass of chromium oxide, chromium 3 oxide. So that's 52 is chromium, and 3 oxygens is 48. What does that give you? 100. Oh, that's a nice molar mass. Is that right? 52 plus 48, yep, that's 100. So that would mean, divided by 10, that's 0.114 moles. Now, it's a 1 to 3 ratio. Let's multiply that by 3. 114 times 3. This will give you the moles of magnesium. And how do you convert moles into mass? You multiply it by magnesium's relative atomic mass, which is 24.3, and that will give you the answer. .3106, 8.3. That's not right. What is the minimum mass of magnesium required? Just type that wrong in the calculator 1 minute. 0.114 times 3 gives you the moles of magnesium. We're done. And then multiply the answer by 24.3. 8.31, which is not one of these answers. We got a problem. What is the minimum mass? What have I missed? Aha. I just spotted it. There's 2 chromiums, and I've only done 1 here. So this should be another 52. Let's try that. So 52 plus 48, 152. Apologies. 11.4 divided by 152 gives you 0.075 moles. 0.075 moles. Multiplied that by 3, multiplied by 24.3, gives you 5.47. Rounded to 3 sig figs. Answer is D. Let's see what the mark scheme says. Number 5. Yep, that's correct. Yep, just a little glitch there. Apologies. Next question. A student is supplied with this volume and this concentration of magnesium iodide solution. A student plans to dilute this solution so that the iodide concentration is this. What volume of water does the student need to add? Let's have a look at this. Now, let me have a quick think. So you've got that concentration. Okay, so what we'll do volume divided by 1,000 to convert to decimeters cubed. Then you got the concentration. You see, this gives you 0.1 times 0.4, which is 0.04. My mental maths is letting me down. Let me just double check this. And 0.4. Yep, 0.04 moles. Now of MgI2. Now you see the moles of iodide ions in there will be double that, because you've got 2 moles of iodide ions per mole of magnesium iodide. So we will multiply that by 2. 0.04, multiply that by 2, 0.08 moles of iodide ions. Now, if we know that N divided by C is equal to V, using the NVC formula. So let's plug that in. 0.08 divided by the concentration is given here in the question. Just put that over here. 0.250. And it wants it in centimeters cubed. Let's multiply that by 1,000. 0.08 divided by 0.250 times 1,000. That gives us the answer is 320. And going back to the question, we are supplied with this much, 100 centimeter cubes we're supplied with. How much does the student need to add? A lot of students would go for this answer. But remember, you've already got 100 centimeter cube volume. How much more water do you need to add? You need to add 220. So the answer would actually be C. Yep, and the mark scheme supports that. So most students, I think, can get up to here, but they write the wrong answer because they didn't read the question carefully. Please be mindful of that. In this question, they're asking, what is the order of increasing first ionization energy? Before we even do this, just a reminder with ionization energy, first ionization energy, my periodic table, it's a bit off, put your hydrogen here. You see, as increasing ionization energy, you have to go up the group and ionization energy increases. There's fewer shells, less shielding, and you need to go more towards the right because there's a greater nuclear charge and greater nuclear attraction. So both these directions increases the nuclear attraction. So we want to see which order do these fit into. Now, let's look at calcium. So calcium, you're going to be going, let's use a highlighter. For calcium, you'll be going from calcium to silicon, phosphorus, and then sulfur. It's calcium, silicon, phosphorus, and then, wait a minute, calcium on the periodic table, silicon, phosphorus, and then nitrogen going up. This actually supports it. I would go with A. A is the answer. Let's see why the others are not. Nitrogen, phosphorus. Oh, this is the reverse. No, wouldn't be that. Wouldn't be that. Calcium, nitrogen. So where's calcium, nitrogen, calcium, nitrogen? So it's going up and to the right. And then you're going phosphorus down. No, can't be that. You got carbon, silicon. So you're going down. You're going down the group, even these two. Your ionization energy decreasing. So no, wouldn't be these. Answer is A. Moving on. The bond enthalpies are given in the table. You see there's different ways students remember this. Some students remember this as when you're given bond enthalpies of reactants minus products. They just remember that rule. I like to use Hess's law, and you see in Hess's law, we're trying to work this route out, but we don't know what it is. But we do know the energy required to convert these molecules into gaseous atoms. And by doing this, we then go like this in that direction, and you're going with this arrow, but you're then going against this arrow, the other arrow. So it's going to be reactants minus, because you're going against the second arrow. And so what would the answer be? Reactants minus products. So there's 4 HS bonds, 4 times 3, 4, 6. plus 3 times 498 minus, let's open a bracket, let's open another bracket, minus, what's SO2? There's going to be 4 S double bond O times 531 plus there'll be 4 OH bonds. And close the double bracket, and that will give you answer. Let's have a go on the calculator. I've got here minus 1102. Does the mark scheme support that? 8, yep, B. That's the beauty of using brackets in your calculator. If you don't use brackets, there's always room for error. B is the answer. Moving on. This is an interesting question. You see in here, you have an equilibrium system of this, and it says different amounts are added to 4 containers as shown below. Which container would have the largest concentration of carbon monoxide? So we are looking at which one would, at equilibrium. So we are looking at carbon monoxide, we're looking at this column. You see, pay careful attention to this. In container A, when we add all of these, because there's no products, there's going to be a tendency for the equilibrium to shift to the right. If you shift to the right, it's going to be less than 1 mole left in the container. If you look at B, there's 0 nitrogen dioxide. So the tendency of the mixture is going to be to move to make some nitrogen dioxide. And that's going to end up giving you greater than 1. C, again, you got 0 nitrogen monoxide. The equilibrium will shift to the right to try bring that amount up. And in the process, carbon monoxide will get used up. So there will be less than 1 mole. And the last one, because there's 0 moles of carbon monoxide, equilibrium will shift to the left. And you see, this would still be less than 1 because it's dependent on the products, which there's only 1 mole. All of that 1 mole would not convert to carbon monoxide, only a portion of that. So really, your answer is going to be B, 9B, yep, and that's correct, according to the mark scheme. Quite a bit to ponder on that. Next question. An aqueous solution of ethanoic acid is given. You've got the concentration. You've got the pKa value. What is the pH of ethanoic acid at that temperature? pH. You see, what is the pH? So Ka is equal to, first of all, let's write the expression CH3COOH. So weak acid, which partially dissociates. And so what you've got here, you see the CH3COO minus ion actually is the same concentration as H plus. So what we can do is substitute the ethanoate ion and make this into H plus squared. So this Ka is going to be 10 to the minus 4.76. Why is that? Because 10 to the power of minus pKa is equal to Ka. This, we assume the concentration to be virtually the same. Only a few molecules out of 1,000 actually dissociate in weak acids. Oops. This should be the weak acid. Apologies. And this is 0.50, and we can work out H plus squared, and we then just take the minus log to the base 10 of that H plus. So we work this out, we rearrange it, we square root it. And so what will I write on the calculator? I will write 10 to the minus 4.76. That gives you the Ka value, 10 to the power of minus 4.76 multiplied by 0.5 gives you that. Then we're going to take a square root of that answer to give us the H plus concentration, and we're then going to plug that into the minus log to the base 10 expression. I've got 2.53, which is the answer A. 10, yep, mark scheme supports that. This question, the feasibility of a reaction depends on the temperature and the signs delta H, delta S. You see, remember, feasibility is whether delta G is less than 0. This makes it feasible. If it's greater than 0, it's not feasible. And using the expression delta G equals delta H minus T delta S, we're trying to see which row has signs for that is feasible at high temperatures, but not at feasible at high temperatures, but not feasible at low temperatures. Let's have a look. Let's go through all of them. You see, if delta H is positive, if that's positive, and delta S is positive as well. Now the thing is, at a high temperature, only at a high temperature will the magnitude of T delta S be greater than delta H. Only then delta G would be less than 0. So actually, what is feasible at high temperatures, but not at low temperatures? Yeah, if we got a low temperature and you're multiplying a positive value, that means when you do delta H minus this lower value, its delta G will be greater than 0. I'm going to go with A. Let's look at the others. Let's look at B. B is delta negative. You see, you know, if B is delta negative, minus T delta S will always be positive, always. Positive, and another positive will just make it positive. Delta G will be positive. No. Delta H, if that's negative, and delta S is positive, negative, negative, and positive, this is always feasible. Whether this, yeah, this will make it feasible, but at a high or low temp. And D, negative, 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 and that's negative. This will only be feasible if you got minus T delta S, and that's negative. That becomes now a positive. A negative plus a positive, this will only be feasible at low temperatures, not high temperatures, D. So this is, it can be feasible, but only at low temperatures. 11A is what we've said. A, yep, that's correct. A is the answer. Ladies and gentlemen, in your textbook as well, depending on which one you use. There's a table like this. It's worth learning and going through the examples as we have done here. Because in these type of questions, this type of question is usually worth a couple of marks, worth looking into. We're nearly done. Two redox systems are shown below. Which species in the two redox systems is the strongest oxidizing agent? Strongest oxidizing agent. Oxidizing agent means it is gaining electrons itself and oxidizing the other, what it's reacting with. So you see in this reaction, the more positive the electrode potential, it has a tendency towards the right, gaining electrons. And the more negative it is, it has a tendency to lose electrons. So what's going to happen? An oxidizing agent will gain electrons. So this will gain electrons. And yep, I think Cu2 plus is the only one in this setup. Oh, actually, wait a minute. You see, no. It's still going to be copper because you see, even though Fe2 plus can gain electrons, but its value is more negative, which means it has a tendency to, the equilibrium has a tendency more towards the left, again, depending on what it's reacting with. So I'm going to go with Cu2 plus. 12, yep, the answer is C. Have a think about that. Which statement explains the trend in boiling points down the halogens group? You see, as you go down the group, the London forces become stronger. So point 1 is correct. The covalent bonds become stronger. We are comparing versus F2 versus I2. You see, because fluorine is much smaller in size, is a greater nuclear attraction towards the electrons being shared. It's going that to break that bond is going to be more difficult. So down the group, this covalent bond does not become stronger. The permanent dipole-dipole interactions become stronger. No, the halogen is between the halogen and itself because they are diatomic, and the electron negativity of two atoms of the same element will be the same, so it will not form a permanent dipole that you get in example HCl. Permanent means chlorine in this example is permanently more electron negative than hydrogen. So the answer is going to be 1 only, 13D. Yep, and that's correct, according to the mark scheme. Next question. Which statement about the molecule is correct? You see, nitrogen forms a double bond with oxygen and a single bond with chlorine. Why have I drawn it like this? Because you've got a lone pair there. It is a polar molecule. Yes, because chlorine is more electronegative than nitrogen. And oxygen is more electronegative than nitrogen. That makes this delta positive. And there's an uneven distribution of electrons, so it will be a polar molecule. It contains 6 lone pairs. Let's see. 1, 2, 3. So 1, 2, 3, and 4, and 5, and 6. Yep, that's correct. It has a bond angle of 180 degrees. No, it doesn't. Using the electron pair repulsion theory, it's got 3 3 regions of electron density which will repel each other as far apart as possible. You're looking at a bond angle of about 120 degrees. So no, not 3, 1 and 2 only. Yep, that is correct. Answer is B. And the last question, you got this compound, it's a ferrous ammonium sulfate. Ferrous meaning this is a commercial, it's used in agriculture for different types of soils. Is it used for, not acidic soil? I think so. If they want to make the soil more acidic, this is used. It gives you a lovely blue crystal by reacting iron with sulfuric acid and some ammonia. So if you react it with cold sodium hydroxide, will it give you a green precipitate? You see, you got 2 sulfate ions. You got 1 ammonium ion. That means iron must be 3+. And iron 3+ does give you a red-brown precipitate with sodium hydroxide. So that's correct. Green is for Fe2+, so it's not going to be 1. Will it give you a white precipitate with barium nitrate solution? Barium nitrate solution. Barium ions react with sulfate ions to give you a white precipitate. This is a precipitation reaction, testing for sulfates. You've probably done this in GCSE. This is correct. And the last one, you see this word, this term warm. If you use warm sodium hydroxide, you see the NH4+ and OH-, which is warm. It goes on to give you water and some ammonia is released. Ammonia is an alkaline gas. So, ladies and gentlemen, 2 and 3 is correct. We will go with C. And the mark scheme supports that. Thank you very much. I will see you next time.